Welcome to today's Enterprise AI World webinar, brought to you by CrateDB and SearchBlocks. I'm Mary D. Ojawa, co-editor at Enterprise AI World magazine, and I will be the moderator for today's broadcast. Our presentation today is titled Unlocking the Power of Semantic Search. Now, before we get started, I want to explain how you can be a part of this broadcast. There will be a question and answer session, so if you have a question during the presentation, just type it into the question box provided and click on the submit button. We will try to get to as many questions as possible, but if your question has not been selected during the show, you will receive an email response to it within a few days. And now to introduce our speakers for today. Simon Prickett, Senior Product Evangelist, CrateDB; Timo Selvaraj, Chief Product Officer, SearchBlocks Software, Inc. And now let me pass the event over to Simon Prickett, Senior Product Evangelist, CrateDB.
Hello. As Mary D says, my name is Simon Prickett. I'm the Senior Product Evangelist at CrateDB. I work in developer relations. And for this session, I wanted to talk a little bit about how semantic search can be enhanced with context-aware results from other types of data. So let's jump into that. And first off, let's look at what are the different approaches to searching. You know, we hear a lot about searching for things. So what are some different ways that we can go search for things? One of those would be keyword or full text search. This is typically used with text data, and it requires sort of exact-ish matches. So there's some level of fuzziness. We could use synonyms. We could require phrases. But at the end of the day, the user or the person expressing some sort of search intent has to have some sort of keyword or match to something in the data that's pretty direct. So that's full text search. There's geospatial search, which is something that's probably less commonly talked about, but is extremely important. You know, if you work in something like retail, a lot of the users' search context is going to be based on where they are at the minute. Are they actually in one of your stores? Are they near one of your stores? Are they maybe in a competitor's store? Knowing that can be really, really helpful. So search data generally requires spatially formatted data there's a couple of popular formats. So GeoJSON would be one, or WKT, well-known text, would be another. Those are both formats for describing places on the earth and also shapes. So for example, the outlines of countries or states, or your store if you're a retailer, or if you're going to get really specific and you're a department store, maybe it's, you know, part of the floor of a specific store and knowing what is sold there. Those sorts of search queries tend to involve questions like, what is within this area, or what intersects with this area, or how far away is something from something else? And then sort of the main topic of today's session, semantic search. These are concerned more with meanings and intent. So where a full text search might require the user to be reasonably specific about what they're looking for, a semantic search is going to look for the sort of hidden meaning in the user's query. So things that they might not actually say explicitly could be covered by a semantic search. So for example, if they want to go on holiday to Europe and you have data that only talks about individual countries, then a full text search is going to struggle to understand that France, Germany, Italy, Spain, etc. are all part of Europe. A semantic search with results that have come from an appropriately trained model would know this and will be able to fill in the gaps. Also, semantic search tends to be available across more than just text data. So for example, you might, again, if you're a clothing retailer, you might receive an image from a user that says, find me some shirts that are similar to this one, or I like this shirt, what have you got for me that either, you know, matches these colorways or this sort of pattern? And a semantic search is going to be able to answer those sorts of questions, whereas a keyword search is going to struggle. You would need to take sort of image recognizer, pull some actual words out of the image and then run them through a keyword search. And really, where the power in semantic search lies is partly in the ability to have these other things and contextual data in there as well. So once you've got the intent of what a user wants, being able to add other things that you know about and being able to serve up results that match with additional context is really important. So you hear people talk a lot about hybrid search. What do we see hybrid search being? It's essentially a way of combining multiple approaches. So the three search approaches that we looked at earlier, combining at least two of those to improve the relevance of search results. And what are the problems with this and some of the getting context for semantic search results? Well, quite often it is because your data is kind of all over the place, and there's probably good reason for that. So if you have, for example, geospatial data, it might live in a geospatial system that is good at answering those sorts of queries. If you have document or say product overview data, it might live in a document database, which is good at being searched for those things. Traditional tabular data may be in a SQL database. And you can start to see that things get quite complicated with combining these. And then when you go and add the sort of vector representations that you need for semantic search, you'll find that sometimes you end up with another specialized data store for those. So whilst you can perform that search very, very quickly there, what you might see is that assembling the results of everything else that you need to put a sort of contextually relevant package back to the user of search results with context, with, for example, stock information or alternative products or whatever it is, directions to the nearest store, you're going to need to combine all of these things. And that starts to take time. And certainly in sort of web retail and other channels, these sorts of latencies are the same as an outage. The slower something gets to get results, the less likely the user is going to hang around and wait for them. They'll move on to something else. So what is CrateDB and how can it help with this? CrateDB is a database. It's a distributed database that understands SQL, and it stores all sorts of different types of data in one place. So we say it's a hyperfast open source database for real-time analytics and hybrid search. So today we're going to focus on the search aspect of that. And here's an overview of what CrateDB looks like. In the middle there, you can see there's all sorts of different data types that you can store in the database. So you can have traditional tabular data, you can store JSON or document data of arbitrary complexity, time series data, geospatial, and for semantic search, we also support storing vectors. There's full text search over text data that's provided with Lucene. And the advantage of doing all of this is all of these different data types and access methods can be put in the same place and queried with native SQL that you probably understand already. So one place to put all of your data, and we'll see how that works with different types of data in a moment. So first off, we'll start with some full text search. Why am I starting with that when this is about semantic search? Well, we're going to talk about unlocking the power of semantic search with other types of things. So we'll see how to combine semantic with this sort of search in a short while. So what can be searched by full text search? Well, in CrateDB, anything that's text, including text that's deeply nested in an object data structure. So if you've got a sort of product catalog or some JSON type thing that describes whatever it is that your domain entity is, and that has an existing structure, you can bring that structure here and start searching it without having it to do any work to prepare or change the structure of your data. And how does that work? Well, we create full text indexes. We use Apache Lucene to do that. And then you can query those using standard SQL. So we'll see how that works shortly as well. And also you can mix them with other data types. So you could do a full text search and filter it by something else, like say the amount of items in stock or the distance from a given location. So here's how we go about creating a full text index. What we do is we have a normal SQL create table statement here, and then we've got a field here that happens to be inside an object, so a document-like structure. And we said, okay, the field's called description, it's text. We want to index it as full text, and we're going to say that the language is English. And note here as well that we've got other sorts of content in there. So we've got a geo shape in there for the boundary of this data talks about areas in the city of Chicago, so different suburbs. So we've got a description of the area, and we've got the boundaries, the geographical polygon within which the area falls, and other data mixed in there. So they all go into the same table. We don't have to put them in different places and do complex operations on them. We can also create an index that uses more than one field. So here we've got a full text index that indexes the description of the areas and also the names. And then when it comes to querying them, we write a select query and we just say where match, I want to match the full text field, so the description field in this case, against a keyword. So I'm asking it for areas that have the keyword railway or words that stem from railway. And here you can see an example of what we get back. So we get a relevance score, we get the name, and we get the description. And then what I can do here as well is something slightly more complicated. So here I'm looking for community areas and selecting some of the fields from them, where those community areas have a match for both railroad and historic. So, and also where their population is greater than 50,000 people. So we're mixing the full text with the relational sort of query again and having a slightly more complex query. And we'll get things back that have, words that stem from historic, so historical, and also railroad, and they need to have both of those in the result. So moving along a bit. So in order to do semantic search, we have to create vector embeddings. So how do we store those in CrateDB? Well, vectors are numerical representations of data items. So whatever the original data was, an image or some text or something, it's been crushed down, run through a model, and turned into a stream of numbers. And these numbers are then used to sort of compare and quantify the features of the data. And how that is organized depends on the model that you use. So some models will be trained on text and understanding general purpose English or whatever natural language it is. Other models will be trained on an image data set and so forth. So this happens outside of the database. And basically, the vector is there to take this sort of complicated data and turn it into a format that can be compared mathematically. So comparing lots of numbers mathematically is something a computer can do very quickly. It's something a database can do very quickly. And that's the core of getting semantic search in a database. And in CrateDB, we have a column called float vector that's used to store these. So it's, as I say, a lot of numbers. Think of it as a big, long array. So how do we store the vector data? Well, we add another column to the table. So here we've got, let's store the text of the area's description, and we've created a vector of it. And our vector's got 2048 dimensions. That's been created by a trained model, and it just lives here in the table alongside everything else. So alongside our full text index there, and our geospatial and all of our other data. So everything in one place. Then how do we create the embedding for that? Well, there's many ways of doing it. It depends which AI provider you want to use, which models you want to use, and how you want to go about this. But here's a simple example that just use OpenAI's text embedding 3 large model, and we just run it through their API, get the text that we want to create an embedding for, and we get 2048 vector dimension vector back, which we then store in the database. So storing those in the database is, again, standard SQL, very easy. So we just update that community areas table and store the vector in the column that we created for it. And then when we want to do a semantic search query on it, what we have to do is we do KNN, so nearest neighbor match. So we run a statement that looks like this, and we say where nearest neighbor match between the vectorized field or column in the database and a query vector. So to write a query for a semantic search, we need to take our query, create a vector of it in the same way that we did with the original data. And then the KNN match function in the database can compare that to things that are in there, find vectors that are most similar to it, and it'll be doing that in a semantic way. So it will be able to find things that have properties that weren't necessarily expressed in the user's query. So they're sort of, I was saying, if you talked about, I want to go to Europe, you would now probably get matches for France, Italy, Germany, and so forth, if you'd use the correct model to create the vector. So here's the vector column to search. Here's the query vector. So in this case, we're asking the database, well, okay, which neighborhoods that it knows about in this table, this is a table of neighborhoods in Chicago, are associated with European immigrants. So which descriptions for the neighborhoods talk about European immigrants? And what we get back here is, again, a relevance score, the name of the neighborhoods. And if we look in the description, none of these actually explicitly talk about European immigrants. So full text search wouldn't have got this necessarily. We'd have needed a lot of synonyms. But semantic search understands that European consists of all of these different countries and different areas, and is able to pull those results out. So moving along, we said we'd look at some hybrid search. So how do we combine these two methods, and why might we want to do that? So here's our full text search again. So we've just wrapped this up in a clause in SQL, so we can add another one next to it in the same query. So here we're looking for community areas whose description contains the keywords European or immigrants, or words that stem from them. And here we're doing a vector similarity search. So we're doing KNN match on the other version of that column, the vectorized version where we created and stored the embeddings. And we're using our query vector from the previous slide that talks about European immigrants. And then what we do when we've got these two clauses is we just run a select query that says, oh, I want the scores for each type of search there. And I want to do a join between these two sets of results. So we get them in one single place. So one table, two subqueries, one join over the results, and we can expect to get something like this. So for different neighborhoods, we get different scores from each search type. So in some cases, the full text thinks it's a good match and the vector's not so sure, or the semantic's not so sure. In other cases, semantic search got a match where full text wouldn't have. And what you could do is take these results, sort of normalize those scores, and decide which ones to go with or what to trust based on the two numbers that come back. So this can also, because everything's in the one database, be combined with other things. So we could, for example, say, oh, I want to move to Chicago where we have these community area data set. And you might say, for example, I've been to the neighborhood Hyde Park and I really enjoyed it there. So, okay, semantic search, tell me which neighborhoods are similar to Hyde Park. So what we've got is a vectorized version of the description text. And what we're doing here is saying, do a KNN match on those and compare them with that vectorized description for the Hyde Park neighborhood. We're saying essentially find me neighborhoods that are semantically like Hyde Park. And then we can add some other clauses in. So previously we put full text search in there. This time we're going to say, oh, let's do some geo search. So I also want community areas that have at least some part of the community area is inside an area that I want to live in Chicago. So maybe for work reasons or something like that, I want to live in that sort of polygon that's drawn on the map over there on the right. And I want neighborhoods that kind of feel like Hyde Park. So we're combining a semantic search with a geospatial search to help the user get the full power of what's available to them from the data set. And then how do we go about integrating with things? So, there's a lot of power in here and lots of good stuff with doing search and pulling data and so forth. But you also need to, as part of a tool chain for this, fit into something to generate the embeddings. And then you need to fit into a sort of RAG pipeline for feeding these results into an LLM or something that's going to present them back to the user in a more natural language way. And CrateDB works with standard SQL, as I said, so that helps greatly with integrations. It also supports the Postgres wire protocol, which opens up a lot of tools that already exist and know how to talk to Postgres. So if you want to try this out and use it in a wider tool chain, which you are going to need to build a sort of end-to-end RAG pipeline, then CrateDB makes a fantastic database for storing all of your data, contextualizing, aggregating, and searching through beyond just the vector embeddings or the full text search, all of this other stuff. So geospatial, document data, and any other relational data you've got. And SQL and Postgres wire protocol integration make it relatively easy to use this with other tools that you're either already familiar with or have selected as best of breed to build your pipeline. So if I can leave you with one thing, it would be go and have a look at the CrateDB Academy, which is at cratedb.com/academy, and take one of our online courses. You can learn all about the product and how to use it in different situations, including most of the search concepts covered in this short talk. And with that, I will hand back to Mary D.
Well, thank you, Simon. And now let me pass the event over to Timo Selvaraj, Chief Product Officer, Searchbox Software, Inc. Timo.
Thank you, Mary D. Good afternoon. My name is Timo Selvaraj, Chief Product Officer at Searchbox, and today I'd like to talk a little bit about unlocking the power of semantic search. Let me start with a couple of questions. What is semantic search? How is semantic search different than keyword search? How does it impact relevance when finding information? And to provide a short answer to these questions, semantic search understands the intent behind query instead of just looking for exact matches of terms. Semantic search improves relevance over keyword search. Semantic search uses a vector index to embed and retrieve numerical data representations. What are the challenges facing enterprises today? There are a couple of them, and I want to touch upon these challenges and how we can address them. Solution complexity. In the last 2 years, a lot of products have come out to enable AI solutions, Gen AI use cases, and a lot of them have too much interconnects or too much glue, too many moving parts. Ingestion from multiple company data sources is a challenge. Lack of LLM data privacy, sharing private data with external sources, APIs, endpoints is a challenge. Unpredictable costs. The cost of embedding models, the cost of re-ranking models, the cost of inference is a challenge. It's really difficult to predict how many tokens you may be having in your document repository. And finally, challenges with retrieval. As you are implementing RAG-based solutions, retrieving the wrong content doesn't really help with enabling any type of Gen AI solutions. So Searchbox is essentially providing search solutions since 2003 for 600 plus customers globally. We are a major player in the IDC MarketScape, worldwide knowledge discovery software for external use cases 2024. We are also a major player in internal facing use cases 2023-24. We are also part of the IDC Marketlands as well as the Gartner Magic Quadrant, and we provide solutions for enterprise, workplace, e-commerce, and website search. A couple of our customers, in terms of who uses us, who relies on us for their search requirements. Let me talk a little bit about unified search at your organization. Every organization is looking for a unified search approach, which includes semantic plus keyword, what is being now talked about as a hybrid search approach, where you have a single search that can go across multiple websites, document repositories, internal systems, database records, products, videos, images, as well as FAQs. And these are primarily feeding into use cases for search, RAG, retrieval augmented generation, AI chatbots, as well as what is emerging as agents for using this data to perform different types of tasks. And Search AI comes with multiple connectors, over 300 plus connectors, to enable this integration across your data landscape. And when search is enabled, what customers and employees are looking for is multiple touch points for the same data. So you could have websites, products, documents, internal systems, videos, database records, images, frequently asked questions that could have both internal facing use cases as well as external facing use cases. Internally, you could have employees accessing them as well as contact center or back office operations going back to the same data. Externally, you could have a website, mobile access. You could also have a authenticated access or a portal type access where it's secured, where customers are coming in and accessing the information. Now, how do we look at hybrid search? Hybrid search combines both elements of vector as well as keyword search. Now, keyword search looks for exact words or phrases in the text of the documents, and semantic search basically analyzes the query to understand the user intent and leverages understanding to retrieve results that are likely to be useful to the end users. Keyword search is limited to the vocabulary and grammar of the language used in the query, whereas semantic search or vector search can understand the intent behind the query and can look into similar concepts, synonym related information. And keyword search looks at documents that contain exact keyword or phrase in the query, whereas semantic search can match the intent of the query rather than just matching the word or the phrase. Keyword search can provide relevant results as well as challenges in terms of accessing related information, whereas semantic search can be more effective in looking at user query or conversational queries, which may not be explicitly stated in the query itself. Now, hybrid search combines the best of both of these approaches and provides a very unified set of search results using multiple mechanisms, including re-ranking the results to provide a more specific information back to the end user. Why is hybrid search better in terms of providing results to your end users? Now, when a user searches for a query, in this case, via hybrid search pulls information back from a keyword index as well as a vector index. Now, the keyword index could be a traditional BM25 type index where it's looking for matches, bringing back the popular results that are coming back, whereas the vector index can bring back information in terms of doing a query for a KNN type search, where it's looking for similar concepts. Now, the hybrid search is able to combine them together and rank them based on the fusion values of both these elements coming back together. Now, this provides more relevant results where it combines information where keyword matches are happening as well as similarity searches happening. And this enables you to use this for more advanced Gen AI type use cases, including RAG, chatbots, as well as agents. Hybrid search forms the foundation for retrieval augmented generation, where the user may be typing in conversational type queries, as well as a keyword search type interface where the end user may be typing in a question or maybe multiple phrases, or where you can have use cases, everything from a workplace search to e-commerce or a product catalog type search. Now, it is also the foundation for chatbots, where customers can be entering conversational AI type queries or questions that may be put into a chatbot. Those could be used to retrieve information back from the hybrid search and then passed on to an LLM for performing synthesized responses back to the end user, or they can also use for performing specific tasks through agent type architectures. One of the key elements of using semantic search is using vector embeddings. Now, vector embeddings require you to use embedding models that have to be built into the product. So when you are running in through the text, these vector embeddings are converted into numerical representations for efficient vector storage and retrieval. So you have the embedding model. You also have something called a re-ranking model or a re-ranker, which is going to look at the information that's coming back in terms of a combination of semantic search as well as a keyword search to re-rank these documents or the passages for RAG, and then provide a more unified set of results which are relevance ranked. And finally, you are also using an LLM which can be optimized for RAG that can enable you to look at the conversations and also respond back to your end user in terms of conversational AI and queries that may be coming back. Now, providing this as part of a private or on-prem LLM ensures there is a high security as well as a high privacy for the data. You are not going to external API endpoints or using external endpoints to ensure that your data can be re-ranked or optimized for rank. Now, there is a cost to managing, embedding, re-ranking, and inference models. Search AI, which is our product, basically ensures that they are built into the product itself, so you don't need to be counting the number of tokens or API calls that go to external endpoints. They can be managed internally, and each document can contain hundreds of thousands of tokens per processing, which may make the cost calculation unpredictable in terms of how many tokens you're going to be handling and what your cost is going to be looking like when you're using external API endpoints. The inference costs for RAG, search, and chatbots can be unpredictable due to usage uncertainty, where you may have a certain number of users coming to your site on a daily basis, and it's really difficult to predict what the usage requirements are going to be in terms of calculating costs for inference as well as re-ranking and embedding. Gen AI ROI needs to have fixed cost pricing model versus a variable cost for successful implementation. Now, searching in terms of using something like a semantic search enhances how you search for information within your own repositories. For example, typing in Wi-Fi versus internet, it's going to find the same information. If you're looking at a standard keyword search where it's going to look for specific instances of those terms, here it's automatically going to look for all the variations of that as well as related information. So you're going to manage to find the information even without manual work. And typically in a standard keyword setup, you could be typing in synonyms or you could be expanding it out using manual methods to expand the search out in a traditional architecture. Whereas in a semantic search environment, you will be able to find this without additional work. Now, one of the challenges with finding information is where you have documents which may have poor or missing titles or descriptions. And our product, Search AI, can automatically fix these titles to provide more relevant information that can be accessible to enhance the findability of the information. Within the product itself, we have the ability to crawl information and directly find and fix these titles, descriptions, as well as topics. As the crawling happens, we are able to extract the content from the information and run it through an LLM, and the LLM can generate more appropriate and relevant titles, descriptions, and topics, which can be utilized for better access to the information where the users can come in and find the information without any challenges. Now, pretext NLP helps you find information with specific titles, descriptions, and topics. In many of the documents that may be within your organization and repositories, there may be a lot of duplication of titles and descriptions, or maybe lack of them because the author may not have had the time to put in, or maybe they are legacy documents where they don't have the appropriate title being set up. Now, pretext NLP can go through them as part of the crawling process and enable them so they are accessible to your end users. How do you compare hybrid versus keyword search on your own content? So one of the biggest challenges customers have been facing is as they implement solutions like hybrid search, comparing it against their own existing keyword search systems to show the value to your business users. Here we are providing a ready-to-use plugin within the product which will compare and show you how the terms may be being contrasted with your existing keyword systems and using a hybrid strategy where you will be able to adjust between keyword and vector. So you can adjust the rank weights to use 50% keyword strategy versus 50% vector search and provide a more holistic approach to hybrid search. Comparing the original titles versus LLM generated titles is key for your business to look at and approve to see where they can apply the LLM generated title and see how they perform. And that's something we have built into the product itself. So your end customers as well as your business users can look at it to identify where an LLM can create a better title versus using a human generated title that you may currently have in your system today. Now, within the platform itself, we support the ability to set up hybrid search, AI chatbots, and agents on the same data. You can ingest structured and unstructured data. We have 300 plus built-in connectors. You can pull structured data from CSV data sources like databases, MySQL, Postgres, or any other type of structured data store, as well as documents. We support 40 plus document formats and almost for close to 40 different language variations, where you'll be able to ingest the data for hybrid search, AI chatbots and AI agents. And natively, we support the ability to enable RAG on the platform. Now, RAG is becoming a standard in terms of how you can enable GenAI use cases for using your LLM to synthesize summaries, better information. And it also allows you to auto-generate titles, descriptions, topics right on the same platform. Now, all of this can be done on the platform through a private LLM. We support within the platform a private embedding model, private re-ranking model, as well as a private LLM to enable all of the processing to happen right within this framework. There are no external endpoints to go to, and this can be deployed completely on-prem within your own private data center or on your own private cloud. Now, the biggest challenges customers are facing today is in terms of privacy and security, where you don't want your data to be going to external endpoints. So this platform supports this natively on your own data set, where you'll be able to combine to access 300 plus data sources to complete the processing and enable RAG and search on the same platform. Now, I'm going to shift over to a small video that can show this and how it implements on your own data sets. Once you deploy search blocks, which you can deploy from our site, you can enable this by creating what we call as a collection. And collections are basically connectors that can go through different data stores. Here we are going to a public-facing website, CNN, and you can natively enable RAG for a collection. After you enable that, you can turn on and provide the required URLs that it needs to crawl. So in this case, it's cnn.com, just for this purpose of the demo. Once the crawling begins, it will automatically go through and crawl the pages as well as enable RAG and hybrid search. In addition to that, it can also use and create new titles, descriptions, and topics on the content as it's being crawled. Hybrid search can also be enabled here for better relevance tuning. So you do have the traditional keyword search endpoint, but in addition to that, you have the hybrid search where you can basically adjust the weights between keyword and vector and use that to enhance your search relevance. As you can see, as the crawler starts to run, it'll automatically start pushing and crawling the pages and sending the data into the internal keyword as well as the vector index. And once you're able to search, you can actually compare between the traditional titles that are available as part of the page, as well as the LLM generated pages. And you can basically compare and contrast how that information is being generated in real time. In addition to that, you can also compare how hybrid search is performing alongside your keyword search. You'll be able to adjust the weights and look at terms which may be similar, and if the term is coming up, if the document is coming up and relevant. So in this case, you are able to find when you type in meals tax, you're finding the same page versus food tax as an example here. You also have the ability to enable RAG directly on any system and embed in terms of a URL. You can actually use an API call that can be made into the system and directly embed RAG as part of any external system through our API integration here. A standard search page can be adjusted in terms of 100% keywords. So you can still go back and look at what the current BM25 search index may be bringing back versus a combination of vector and keyword search in terms of a hybrid ranking, maybe bringing back, and you can compare it side by side to ensure that you're able to tune relevance according to your specific needs. And these use cases, tuning relevance for different use cases may require you to set different thresholds of using mix and match between keyword versus vector. Next, we are talking about chatbots and how you can enable chatbots directly on the platform. Here again, you can type in a question on any of the data sources that may be available. You can go across data sources and ask questions directly on the system. This again can be embedded anywhere on your site or your external site to support use cases for employee question and answers, as well as customer facing use cases like customer support or ticketing support and things like that. And every conversation that happens to the system is captured as part of an audit, so you can directly go ahead and look at them. Next, we are showing you how agents can be applied on the same data. So you can basically create a workflow in terms of using the data that's already sitting on the platform, where it's using the underlying RAG APIs and answering questions or maybe routing tickets between different data repositories. All of this data, again, can be analyzed in terms of analytics that can be provided, which are real time. Just to summarize, today we talked a little bit about hybrid search and how it makes finding information powerful. Building hybrid search chatbots and agents on the same platform with the same data without doing multiple iterations or storing in multiple places. Using pretext NLP to automatically create titles, descriptions, and topics using the built-in private LLM, and also building a RAG search endpoints where you can deploy it for different types of Gen AI use cases across the enterprise. Thank you so much.
Well, thank you. And now let us get to some questions from our viewers. Let me start with this one for you, Simon. What do you see as the primary challenge with improving the quality of semantic search?
So I guess there's two things there. There's how you get the meaning into your embeddings. So continuous work on improving models and training and so forth. But I work for a database company, so from a database perspective, the primary challenges will be being able to perform those vector queries quickly and efficiently, but then also being able to return the relevant data that Timo spoke about from either other places or from metadata that's stored alongside it in the database. So doing the search is one thing, assembling like a full package of results to go further down into an LLM to create a generative response or whatever else you're going to do with it is another whole area. And that's where I was trying to explain in our presentation that doing that inside the database as like one atomic thing is greatly powerful.
You have anything to add to that, Timo?
I think what has helped us is comparing between the current relevance, right? I think how do you compare what is happening today versus how you're making a difference with the semantic layer? For us, doing that comparison side by side has really helped us in terms of how our tools can assist the end users with that.
I have another question here. I think this one is really for you, Timo. Can I use semantic search with my website to improve the relevance of the search? I think that kind of ties in with some of the things you were saying about quality, but relevance is something that search has always struggled with. So, what can this person do?
Absolutely. So I was just showing in the video, basically we are able to crawl the site and apply semantic search and then do a comparison between what they have today, right, in terms of keyword search versus comparison and so what the hybrid search can do for them. And I believe every website out there needs to go back and evaluate how their current search is performing and how semantic search, basically the hybrid search, which combines both elements to make an improvement. And relevance, you're absolutely right. Relevance has been a long-standing challenge with every site out there, and this is something that can eventually, solve using some of the newer techniques that we're using now.
Excellent, excellent. Simon, how is semantic search enhancing customer experiences in e-commerce, customer support, content discovery?
Yeah, so I think for e-commerce, it's really that, well, what's the unsaid thing in the user's query? So, if the user's looking for, I don't know, a certain brand of something, you might want to suggest them other things. There's sort of quality indicators associated with that brand, for example. So you can tell that they're into sort of premium things. Or with they might come to you with some other sort of query, like, here's me in an item of clothing, or here's a car part. What have you got that works with this? So you have this completely different sort of query that normally you probably have to go to an actual physical person at like a car parts store and present them with this thing and so forth. I think also the way that things are getting enhanced with customer support is people have queries, especially on technical products that cover like multiple things or are specific to a programming language or are specific to a certain case, and understanding beyond just keywords to answer those removes a lot of frustration with these sort of online lookup systems, and again can help people deal with things more at the people actually like using an intelligent chatbot. I prefer talking to my utility company about my payments and why they're taking too much money from me over WhatsApp versus calling a person. And the fact that they can pull up all of my account information and understand what I'm talking about is hugely beneficial for everyone involved.
Timo, anything to add to that?
The one thing I'd like to add is how can they enhance customer experience, e-commerce, customer supported content discovery is the ability to combine structured transactions, right? So when I go to a shop or try to do something, they should already know based on my past purchases, okay, this is what Timo is coming to because he just purchased this laptop and they're looking for support. So combining that with, what type of laptop I had, maybe I'm having issues powering it up, things like that. I think combining structured, unstructured could go a long way in enhancing customer experiences in all of the areas that we mentioned.
Yeah, and I think you have some customers who know exactly what they want and are very knowledgeable, and then you have other customers who are clueless, which presents some problems in what keywords would be appropriate if they don't actually know.
That's right, which is where semantic search could play a huge role in connecting the dots.
Absolutely. Timo, let me stay with you for a minute here. Here's someone who wants to know if he can run semantic search on-prem without any external dependencies or APIs.
Yes, the answer is yes. So our platform can be deployed completely on-prem in air-gapped environments. All the models come with it. And once you deploy, everything runs on a CPU as well. We don't ask for a GPU. We can run on CPUs.
Okay, good to know. All right. I have one very specific question here for you, Simon. Does CrateDB have a CSV import?
Yeah, we do. So I'll plug the course that I talked about at the end. So if you go to our website and take one of our courses, they come with sample data set, and it's about it's open data from the city of Chicago, and that's in a couple of formats. It's in JSON and CSV because that's what Chicago, Illinois provides these things to the world in. And there's several ways you can get it into the database. We actually have a SQL command copy from that copies data from a resource out on the internet, so a URL that can be CSV or JSON into a table, or you can use other bulk loading tools as whatever you've used before that is PostgreSQL compatible will likely work. But yeah, in short, we have an actual copy from command that will pull data in from CSV or JSON out, and that can also be compressed if it's a really large file, and we'll deal with that.
Is there a limit to how large the file can be?
Good question. Don't know, to be honest.
I'm assuming that in the academy you're using relatively small data sets so people can work with them easily.
Like about 250,000 records. So, and those will load in a few seconds once the file transfers happen. Yeah. So.
Okay.
One of the benefits of being a distributed database is we can parallelize some of this stuff.
Right. Timo, let me start over again. Can we compare keyword search and semantic search? Is there an easy way to do that, Timo?
Yes, we provide a plugin that comes with that because we have both the keyword vector as well as the combined hybrid search endpoints. So the plugin that we provide compares what you have today if you just do a standard keyword search on our same platform versus doing a hybrid search, how it changes results. That can be viewed live as you do searches. So that helps customers tune in case they need to adjust the rankings, adjust any of the data that goes through. So it's built into the platform for doing a comparison.
Okay. Simon, I love this question. How can organizations leverage non-textual data alongside semantic search? Because I think non-textual data is something that needs more attention paid to it.
Yeah. So we're a database. So what you could do is, if you're going to do the searches based on non-textual data, you'll obviously need to create some sort of vector representation of those. So if it's images, run them through a model that understands image classification for whatever domain it is you're working with, or an image to text model, or whatever it is. And then store those results in the database, compare them with other things, and return this one package of here's all the results sets. That might also include references to, say, an S3 bucket that contains the actual original image, because storing the actual original image in a database doesn't honestly add that much value. You might as well use something like an S3 bucket and store a reference to it, because that's what you're likely to need. So yeah, there's that, and then just the ability to compare streams of non-textual data as well. So imagine you've got like two sort of binary data things, and they represent some sort of output of a load of parameters from an industrial machine or something. You could run those through a model that understands things about those, and then run vector similarity on those, or semantic search on those. And start comparing them with streams where, say, things have failed or gone wrong, so that you can then start to know when to take these things down for maintenance. So you can perform other sorts of search comparisons for reasons other than getting results back. It's like a workflow thing too. But, what do we think might be about to fail? Then maybe we should take it out of service and do some work on it.
I can think of any number of industries where that would be really important. That is all the time we have for questions today. We apologize we were unable to get to all of your questions, but as I stated earlier, all questions will be answered via email. And I would like to thank our speakers today: Simon Prickett, Senior Product Evangelist, CrateDB; Timo Selvaraj, Chief Product Officer, SearchBlocks Software, Inc. If you would like to review this event or send it to a colleague, please use the same URL that you used for today's event. It will be archived for 90 days. Plus, you will receive an email with the URL to view the webinar once the archive is posted. If you would like a PDF of the deck, go to the handout section once the archive is live. And thank you again for joining us.